Hello, welcome to the second question. Here's the solution to the second problem. Um, the solution can be found in UTS Online. However, I would encourage all students to attempt the tutorial exercise on your own. So to start with this exercise, I will insert a new worksheet. And the purpose of this exercise is to plot simple curves based on an equation that has been provided to you, and to also use solver to locate these roots. The first equation that we are attempting to solve is f of x is x minus 2 times x minus 3. This is a pretty straightforward equation. I'll create a table that contains two values. So the first column will contain x, and the next column will be f of x, also known as y, and also known as the vertical axis. I'll create a range of values for x. So I'll use an interval of 0.1, starting with the value of 1. To automatically fill these values in, I can drag the bottom right corner. It's this square here, also known as the handle, and I'll just fill this to, let's say, until 3.5. The values of f of x will be x minus 2 times x minus 3. Now I'll just copy this cell to the other cells by dragging the bottom right corner, the handle to the other cells, and now I should be able to create a plot. I need to highlight the values, including the titles. I'll then click Insert. I'll choose a scatter plot, and I'll choose a scatter plot that includes both smooth lines and markers. It would be helpful if I were to zoom out just slightly so we can see more of the spreadsheet at one time. All right, so here's our curve. We can clearly see that there are two roots, and the roots are likely to be close to 2 and the value of and 3. In order to locate these roots, we can use a very clever tool known as solver, and solver is inbuilt in a standard installation of in any modern installation of Microsoft Excel. To make solver work, you would need to install it first, or you would need to make it available. So to make this available, I'll click the File tab. We click Options, click Add-ins, and click Go. You'll need to tick the solver checkbox to make solver visible to you. Once you have done this once, it should always be available the second and third time you're using Microsoft Excel. So you'll only need to use this. You only need to do this once. Okay, so how am I going to use solver? I'll do this in a separate part of the spreadsheet. This would be x and f of x, and I'll just put an initial guess here. Let's say 2.2, and f of x will be this formula. So that will be 2.2, which is x minus 2 times 2.2 minus 3. Now, using solver is incredibly simple. You would need to go to the Data tab in the ribbon. We'll click Solver, and there's a couple of things we need to fill in to make solver work. Firstly, we'll need to set the objective. In this problem, we are locating roots, and a root is a value of x that makes f of x 0. So f of x equals 0 is our objective. I'll click this to select the cell that I want to make equals to 0, which is cell E4. I'll just remove this, and I press Enter, and we need to set this to a value of 0. We can reach this objective by changing variable cells. In this case, it's just one single variable cell, and that would be cell D4, which would be X. Now we can leave options and checkboxes alone in this case. And to use solver, I'll just hit the solve button, and it reports that solver has found a solution, and the value of X is 2. Since the value of fx is pretty close to 0, we are happy with the solution, and this is a root, or this is an approximation to the actual root of this equation. So we're happy, and we click OK, and we're done. To make it clear that this is our final intended results, I'll put this in yellow, and I'll make this number bold. That's the first equation. Now let's repeat this with the second equation. The second equation is f of x equals x squared minus x minus 20. Again, the first thing we need to do is to draw a plot of this equation. Our first column will be x, the next column will be f of x. And this time, my initial value of x will be minus 10, and I'll use an interval size of, let's say, 0.5. All right. Now, f of x will be this mathematical equation at the top. So I'll need to convert this sentence into the equivalent Excel formula. This will be x squared minus x minus 20. And I'll just click the cell, drag the bottom right corner to fill the numbers all the way to 10. Or let's say 11. We can now use these numbers to create our plot. So to create a plot, I'll select all numbers, including the header or the title of the horizontal axis and the vertical axis. And I'll then click Insert. I'll choose the scatter plot, and I'll choose a scatter plot with the points, with the markers, and also with a smooth line. So that is, I'll just drag this slightly to the top. We can see that there's going to be a root here, approximately minus 0.4, and there's going to be another root, which is 5. So let's attempt to locate the positive root first, as locating positive roots are simpler than negative roots. This will be x and f of x, and let's use an initial guess of, let's say, 5.5. fx will be x to the power of 2 minus x minus 20. So we can use the solver in the same way to locate the root of this equation. I'll click Data, click Solver. We need to initially set the objective. So the objective will be cell S19. We want this value to be as close as possible to 0, and we want to change the variable cell. The variable cell is cell R19, which is here. I believe I might have selected the wrong cell, so I'll double check it afterwards. So are my cell references correct? Yeah, my cell references are correct. So if I click solve, it should give me the root of the equation. And let's have a look at this. That's right, it's working. X has a value of 5, and this is the root of the equation. The value of f of x is pretty close to 0. So I'll click OK. That's our first root. We can also use Microsoft Excel to locate negative roots. I'll repeat this. And I'll use an initial guess of minus 5 this time. This cell will be U19 to the power of 2 minus U19 minus 20. And I think I'll just move this here so it's a little easier for us to work with. Now, in order to calculate a negative root, you'll need to click solver. We would set the objective. The objective in this case will be cells V19, and we want to set this to a value of 0. We want to do this by changing one single variable cell, and this variable cell would be cell U19. Okay, before I proceed to solve, this is not actually going to work. If I were to click solve, it will say that solver has found a solution, but our solution is the same as our original result. So something is wrong here, and we'll need to return to the solver parameters a dialog to have a good look at this. I'll want to restore original values and put them back to where they were. Now, in order to make solver work with a negative value, you will need to uncheck this box. If you uncheck this box, solver will be able to work with negative variable cells. Once you've done that, you click solve, and let's have a look at the equation. Things appear to be working fine, and solver has now successfully found a negative root, which is x equals -4. We'll keep the solver solution. I'll click OK. I think I made a mistake there. I probably should have unchecked this. So I'll uncheck this. I'll click keep solver solution, and I click OK, and we're done. So our final solution would be x is 5, which would be the first root, and we have the second root, which is x equals -4. The last equation that we're trying to solve would be y f of x equals x to the power of 3 minus 10 x to the power of 2 minus 35x minus. Now, if you were to plot this curve over a large range of x values, you will see that there is only going to be one single root. Now, for the purposes of this lecture, I'll just use a narrow set of values, although I would encourage you to explore this data with a much larger range of x values. I'll use the range of values from 12.5 to, let's say, 13, and f of x will be x cubed minus 10 times x squared minus 35x minus 27. Great. Now, I can now plot these numbers by highlighting all the numbers here, including the letters x and f of x. To create the plot, we'll go to Insert, we'll choose the Scatter Plot, the plot with lines and no lines, and the one with no markers and with marker shouldn't make too much of a difference, as we can still easily locate the roots that we want. And based on this curve, we have a root that's between, let's say, 12.85 to 12.9. We're nearly finished. So we would finish this by putting an initial guess of x, let's say 12.9, and we'll have a formula. I should be able to copy and paste this number here, and that works fine because we are using relative references and not using an absolute reference. So in this case, copying and pasting does work. Okay, now to use the solver tool, we'll go to Data. I'll click Solver. I will then set the objective. The objective is cell AA17, or it's AA18 rather, and we want to set this to be a value of 0. In order to achieve this goal, we need to change the variable cells Z18. And since this is a positive root, I will check this back because I want my variables or the values of x to be positive. I then click Solve, and let's see if this is a good solution. Yes, a great solution. The value of x is 12.8801, and the f of x is pretty close to 0. So therefore, this value of x is a good approximation to the actual root of our original equation. I would then click OK to keep the solver solution, and I'll just highlight this cell to make it clear that this is our final intended result. Okay, great. So I hope you enjoyed this video, and I'll see you in the next one.